Assalamualaikum to Madam. This is our video presentation presented by me, ADRIANNA ALYSSA, and my partner, Sarah ALYA. To start off, for question 1A1, we are going to have to use the combination principle to find the joint probability distribution for fxy. So for x equals to 0, y equals to 2, will equal to 1 over 35, where x equals to 1, y equals to 1, equals to 8 over 35, x equals to 1, y equals to 2, equals to 4 over 35, x equals to 2, y equals to 1, it will equal to 12 over 35. For x equals to 2, y equals to 0, will equal to 6 over 35. And lastly, for x equals to 3, y equals to 0, will equal to 4 over 35. The numbers calculated above using the combination principle will be put into the joint probability distribution table, where all of the numbers will be used to calculate the marginal distribution of both x and y. To find the marginal distributions of both x and y, we will add all of the numbers in their respective columns and rows, where it would be for gx 1 over 35, 12 over 35, 18 over 35, and 4 over 35. And for marginal distribution of y, it would be 2 over 7. We will add 8 over 35 and 12 over 35 to get 4 over 7, and 1 over 35 and 4 over 35 to get 1 over 7, and it will equal to 1. Find whether or not x and y are dependent. We have the equal function xy with gx times hy. And since 12 over 35 is not equal to 72 over 245, x and y are not independent. Moving on to question A2, we're going to find the mean of x, where we're going to use the formula summation of x times gx. When put in the values, will equal to 12 over 7. To find the mean of y, we're going to use the formula summation of x times hy, and when we put in the values, it will equal to 6 over 7.
B. The joint probability distribution of discrete random variables x and y is given in the following table. Number 1. Find the marginal distribution of x and y, hence, the probability of x is more than or equals to 2, given y is equals to 2. From the table, the possible values of x are 1 and 2, while the possible value of y are 1, 2, and 3. To find the marginal distribution of x, we have to sum across all y values. For each value of x, add up all the joint probabilities across every value of y. Same goes with marginal distribution of y. For each value of y, add up all the joint probabilities across every value of x. Finally, the sum of both marginal distribution is equals to 1. Now, using the conditional distribution formula to find the probability of x is more than or equals to 2, given y is equals to 2. Since x takes values 1 and 2, the condition means x is equals to 2 only. Next, substitute the values into the formula, and the answer is equals to 0.6286. Number 2. Calculate the covariance of x and y. In order to calculate the covariance of x and y, the value of expected x, expected y, and expected xy must be calculated first. To find the value of expected x, multiply each possible value of x by its marginal probability and sum the results, and we will get the value of expected x is equals to 1.57. Same goes with the value of expected y. Multiply each possible value of y by its marginal probability and sum the results, and the value of expected y is equals to 1.87. For the value of expected xy, multiply each x and y value, then multiply the probability of that pair, and add all these results to get the expected value of xy, which is equals to 2.88. Finally, substitute the calculated values into the covariance formula, and the covariance of x and y is equals to negative 0.0559. Question 2. In order to find the marginal density of x, we have to integrate over y with the limit from 0 to 4. First, substitute the joint density. And then separate the integral inwards. Next, integrate 2x and y with respect to y. Then substitute the limits and the final answer is 2 over 15x plus 2 over 15 for x between 0 and 3. Same goes with marginal density of y. We have to integrate over x. First, substitute the joint density. Next, separate the integral inwards. And then integrate 2x and y with respect to x. Next, substitute the limits. And the final answer is 3 over 20 plus 1 over 20y for y between 0 and 4. Number 2. Calculate the probability that the sum of x and y is less than or equals to 2. When x is equals to 0, y is equals to 2. When y is equals to 0, x is equals to 2. The inequality x plus y is less than or equals to 2 represents a region below the line y equals to 2 minus x. Together with the origin, these points form a triangle which the probability is calculated. Next, decide the limits of integration. From the graph, y ranges from 0 to 2. For each value of y, x ranges from 0 to 2 minus y. Then, set up the double integral. The probability is found by integrating the joint density over this region. Integrate 2x and y with respect to x. Next, substitute the limits. Now, expand it and getting 4 minus 2y. Then, integrate it with respect to y and then substitute the limits and expand it. And the final answer is equals to 1 over 15.
Moving on to question B1, where it is about the joint probability density function of x and y. So now we will find the mean of x, where we will have to double integrate x times function xy with respect to y and x. First, we have to integrate with respect to y and then with respect to x. After integrating both of them, we will get the final answer, which would be 4 over 5 or 0.8. Moving on to find the mean of y, we'll have to do the same thing with finding the mean of x, which would we have to double integrate y times function xy with respect to y and x. First, we have to integrate with respect to y, and then we will integrate with respect to x. After integrating both of them and putting in the values, we will get 8 over 15 or 0.533. Now we are going to find the mean of xy, which would mean we have to integrate xy times function xy with respect to y and x. After expanding, we would have to integrate with respect to y since it is the inner part, and then we will integrate with respect to x. After putting in the values for both integrations, we'll get the final answer, which would be 4 over 9 or 0.444. Moving on to the next question, B2, we are going to find the covariance of xy, which is the mean of xy minus mean of x times mean of y, where the answer is 4 over 225, which is not equal to 0, which means that x and y are not independent. That's all from us. Thank you for listening. Love you, madam.